Hello, welcome to this series. We have been seeing how to break down data structure and algorithm concepts into simpler steps and doable steps and how to do it. So in the last two videos we saw about data structures and algorithms. This video we are going to see about breaking down and studying problem patterns. Generally when people see problems, they think about doing it and understanding it, working out problems. That is true. There are a lot of problems in lead code. When you try it out, you understand your patterns, and doing helps in learning. But there is some difference. Like when you keep doing lead code patterns, you will not be able to cover all the problem patterns. So when I say problem patterns, I mean two pointer, sliding window, etc., etc. So each data structure has a lot of patterns underneath it. Some of them are very common and known and name patterns, like two pointers. Some of them are not very common. Different people might have named it differently in the resource, some lead code discussion or something like that. I have identified few and I've named things myself in the Notion guide and everything. So problem patterns are slightly different from problems because they have a certain common traits in the problem definition or the solution approach, and this needs to be studied so that when you study and know problem patterns, some more problems become available for you in for practice and for you to solve efficiently. And you may not be able to cover all majority of it just by randomly hitting lead code, because lead code has endless problems. So we'll see how to break down problem patterns and then how to study it. So before going into the details, generally when people study problems, they might it might be of this pattern. There'll be a brute force solution, and then there'll be a little more optimal sort of thing. This may not be always useful, may not be always available, and may not be always the best fit to understand problem patterns. So when you're seeing a problem and then you're trying to understand the brute force solution, how to optimize it further, it is a thought process understanding of how to break down a problem, how to see it in different ways and solving it. Is how to approach a problem. But when I'm saying problem patterns, we are going to actually understand certain known concepts or understood patterns that already exist. So we may not always need the brute force to the most optimal path. We might just quickly jump to what this pattern is, what the example problem is, and what sort of problems and solutions fall into this pattern. Okay, so we may not always need this. So similar to how we dealt with data structures and algorithms, up until this step you need not even touch the code. So every problem pattern will have one simple sample problem which falls under this pattern. So this will be the base example problem with which we are going to understand this problem pattern. So we pick that simple sample problem and then we try to first understand it. Are you able to visualize it? For example, if it is a sliding window, are you able to visualize an array, how the problem is, what is the requirement, how the things are moving, and every problem or problem pattern or the simple sample problem will have input and output. So you need to understand what the problem is, what the input is, what the output is, and how the input is getting transformed to the output. In some problems they might have already given, or you might have to generate multiple alternate input output combinations to cover the depth of it, or cover the breadth of it. So this is an optional step. It might be important for some, it may not be for many. So understand the problem visually, understand the inputs, understand the outputs, and you will also be generally given solutions in visual format. Sometimes it may not be there. So generally problem patterns will have a typical rough structure of how the solution goes. So when we are understanding a problem pattern, we'll try to understand what is the pattern in the problem and also what is the pattern in which we write the solution. So if the visual is not there, you could use the text descriptions. Sometimes they might have just given some code snippets for individual steps. You could use that, or you could actually take certain snippets from the code and then you try to visualize and understand how the solution goes. So once you understand the solution visually, you can then do the analysis of the solution. This can be done just from the visual. Is it O of n squared, log n, what is happening and everything. Sometimes it starts, there's this trade-off thing that might be important. This is where it connects to the brute force to optimal and more optimal approaches. So if it is applicable, you might have to understand how this solution fares well in comparison to other alternatives, and this kind of becomes important in interviews because this is where people ask, why are you using this, what advantage does it give in a different scenario, what would you use, what is the analysis of all these scenarios. And this is where the discussion might tend to go when you're doing interviews, which you will generally not do in LeetCode. Of course, if it's a time limit exceeds thing, you're going to optimize and do stuff, but understanding trade-offs will be helpful for discussion. This may not be there for all the problems, but when it is there, you could check it out when it is applicable. So you try to do the analysis and trade-offs and everything. This you could do just from the visualization, and then the next step is the code walkthrough. So you take the code, you have a rough visual understanding, but what you're going to do is walk through the code step by step. You're going to use the visual, update each step of the visual according to the code, and do the complete walkthrough. So this will solidify your understanding of this particular problem pattern using a simple sample problem. There might be other variants, other more complex variants, or just alternatives. Once you understand a simple problem, you will be able to extend to it easily. You could either read and skim through it, or some problems you can just directly try and use it. You can just go through it. You don't have to do all the detailed steps that you do for the simple problem. So this is how you would study a problem pattern. Bye.